Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is Physics 5054 of GCE, and today we are going to conduct lecture number 29. Very important lecture, so don't miss and see it till the end because we are going to start the structured question of section B, chapter number 5. In fact, topic number 5. So let us understand the question. They given us this figure on the page number 77. Exactly, I portrayed it in the same fashion as it is given in the book. A figure shows a plank of mass 5 kilogram. Remember, ladies and gentlemen, the mass is given as 5 kilogram here, but we will not deal with the mass because we are dealing with the weight, so we have to convert this 5 kilogram into weight, and you know W is equal to mg and m is 5 and g value is given in this question as well. They are saying that g is equal to 10 Newton per kilogram at the very last line of this uh, page. So remember that it is 50. I wrote it here, so I am explaining it in advance. And length is 3 meter. The length of this full plank is 3 meter, but under the consideration area is 2.5 because this area and this area is removed. So we are left only with 2.5 centimeter of the a meter of the area, which is 3 meter, resting horizontally on two trestles P and Q. There two trestle, which one is P and the second one is Q. This plank of wood is resting on these two trestles. So which are a distance of 2.50 meter apart, and you can see we wrote that 2.50 meter apart. When a student of mass 60 gram, uh, when a student of mass 60 kilogram, so we found W is equal to mg60 multiplied by 10 is equal to 600 gram, and I am writing it. Understand the question. Don't lose your concentration. Uh, when a student of mass 60 kilogram walks along the plank from one trestle to the other, the plank sags. Sags means that it is becoming like this. When a student is moving from one point to another point, then it means that the uh, this plank is sagging. It becomes in curved shape. So the student is walking along the plank. Okay, number A part is asking explain why the sag increases as the student walks towards the middle of the plank. why it is. Remember, ladies and gentlemen, I wrote it in detail before the recording of this lecture to avoid the time, but let me explain it. The plank is also having center of mass. The total mass is acting on that particular point, and there is a 5 kilogram is this one, and 60 kilogram is the weight of the student which is moving from one point to another point. Because this student is also having mass as well as the weight, so whenever he is moving, the combined mass or the combined weight of the buoy and plank system increases, and when it is moving to the center, so the center of mass value is increasing, and similarly the center of gravity is also increasing. So it means that this plank will become sagged. uh, I have written it here assuming that the plank is uniform. The weight of the plank act at the midpoint of the plank, as I denoted it by a dot, causes the sag. Only this is also causing the sag because it is also having the mass. As the boy walks from P towards the middle of the plank, as I have denoted, the combined gravity of the system of plank and buoy and the midpoint of the plank causing larger sag, because the mass is increasing, so sag will also increase. As the buoy moves even nearer to the midpoint, the sag increases as the combined center of gravity moves towards center of the plank. So this is the answer of the first part. Now we are turning towards the second part. This figure is not given, but we have made it for the solution of this. What? Part number B. Part number B is saying calculate the downward force exerted on each trestle when the student is at a distance of number 1.0 point when x is equal to 0.50 meter from P. Uh, the student is walking from this P trestle towards the Q trestle, and when he is at a distance of x is equal to 0.50 meter, then what will be the force on this and on this trestle Q on P? So we have to find the force. The distance is given as x is equal to 0.5 meter. Now when x is equal to 0.5 meter from P, mass of buoy is equal to 60 kilogram. It is given to us in advance. So we are finding W is equal to mg. M is 60, and when multiplied with 10 it becomes 600 Newton. Okay, one thing. Now mass of the plank is equal to 5 gram. I'm not writing it from my own side. It is given in the question. So W is equal to mg. So 5 multiplied by 10 is equal to 50 Newton. Remember, we have studied the principle of moments, and here I wrote by the principle of moments, moment about P. Now we are talking about the P. Uh, RQ means reactive force, which is applied by the trestle on this plant. So I am writing RQ and the distance whole from this trestle. Now for this whole, this is the distance which is given to us as 2.50. The whole length is 3 meter, but we are considering as 2.5. So for this it is 2.50 meter. So I wrote this as the anti-clockwise. This will be clockwise. And there are two. One is due to the 600 Newton weight of the weight of the boy, and that is 600 into 0.50 meter because it is given. And then the second one is 50, and that is also of this plank given to us. We found it 50 here. So 50, and that center of mass is at 50 point, middle point. 1.25 is this one. So it means that 50 multiplied by 1.25. When we multiply this with this, we get 300. When we multiply 50 with 1.25, we get 62.5. So 362.5 will become 362.5, and this 2.5 will go to the next side. And when we divide this to 362.5 divided by 2.5, so it will become 145 Newton. Because this RQ is a reactive force, so we can write this RQ as FQ as well. So that will become 145 Newton. Okay, we found uh, this Tristan's force, but we have to find this one as well because it is asked in the question that both the forces you should find. For vertical equilibrium, this vertically, if this is in equilibrium, so R plus P, RP, reactive force at point P and reactive force at point Q is equal to 600 plus 50. We wrote the values of these. So because we are finding RP, we found RQ. Now we are finding RP, and RP is equal to F at P. Force at P, reactive force at P, both are equal. So we have to leave this RP on the left side, and we have to transfer this RQ, but I directly wrote it here minus FQ. So FP is equal to 650 minus FQ. We found 145, and we are putting the value of this FQ is 145 Newton. When we subtract 145 from 650, so it will become 505 Newton, and that is the ultimate answer. So we found two forces, and that is FQ is equal to 145 Newton and F at P is equal to 505 Newton. Now the second part of this question is saying when the student is at 1.25 meter from trestle P. So I have written here when x, that is the perpendicular distance. When x is equal to 1.25 meter from point P. We have to find the force. Uh, when the student is at x is equal to 1.25 meter from P, so where is 1.25? You can see that it is at the midpoint. When the student is at the midpoint, both the forces 600 Newton and 50 Newton. 50 Newton and 60 Newton. One is the weight of the student and the second is the weight of the plank. Act at the center of mass of the plank. By symmetry, Rp is equal to Rq because on this side and on this side they are equal at equal distance. So whatever force R at Q, reactive force at Q it observing, that will be equal to R at E because the person, the student is at the midpoint. So both the forces 600 Newton and 50 Newton act at the center of mass of the plank. By symmetry, Rp is equal to Rq, and we are putting again the value that will be equal to Rp is equal to, remember this point, we will utilize this point later on. So Rp plus Rq is equal to 600 plus 50, and because both are the same, so we are dividing it by 2, and when we are dividing it by 650 by 2, it will be equal to 325 Newton. So as Rp is equal to Rq, so we found the values of one and that will be equal to the value of second one. So Rp is equal to 325 Newton and Rq is also equal to 325 Newton because R at P is equal to R at Q. Ladies and gentlemen, that is the whole story about the question number 1 of structure question. Now we are turning our focus to question number 2. Okay, ladies and gentlemen, now let us turn our focus to question number 2. Uh, Question number 2, A part is saying that what is meant by the moment of force? How can it be measured? Name its SI unit. We did all these things in the previous lectures, but for your memory refreshment, I wrote all the things again. The turning effect of a force applied to a system rotational system at a distance from the axis of rotation. The moment is equal to the magnitude of force multiplied by the perpendicular distance between its line of action and the axis of rotation. For example, I given you, if you remember, the example of the door. When we are applying a force, this is a perpendicular distance and hinges are all the axis of rotation. So that is what I wrote here. Again, we wrote that in that particular lecture as well. The SI unit of moment of force is Newton meter. That was easy. Now the B part, the diagram below shows the plane view of a door hinged at A. you are seeing the door from upward, like this, not like this. You are seeing the door from upward. This is upward and this is hinge. That is given at A. If a man applies a force F of 40 Newton, the F is applied of 40 Newton at the end of mark B. This is hinge, and here 40 Newton force is applied by a person. Uh, Calculate the moment of this force about A. This is the first part. So A star is equal to F cross D. F is given as 1.8 in the diagram, and F is 40 and D is 1.8. So when we multiply, 72 Newton meter is the answer. Now the second part is saying what is the minimum force X that must be applied at C in order to stop the door from turning. So here we are saying that what force we should apply at this X. So the door should be stopped, not to move. So A's clockwise moment is equal to anti-clockwise moment. So it means that x multiplied by 1.2, this is x and this is 1.2 also given in the book. And the second is 40 multiplied by 1.8, which is anti-clockwise, and this is clockwise. So it means that 1.824 divided by 1.2, because we are finding the value of x. So we are making this x as the subject. So this 72, 1.8 multiplied by 40, 72 divided by 1.2, say it will be 60 Newton. Name the principle applied. This is the C part. Name the principle applied to solve this problem. As you can see, we wrote the principle of moments. Okay, that was all about the question number 2. Now we are turning our focus to question number 3. And question number 3 is saying what is meant by the center of gravity of an object. We talked about the center of gravity in previous lecture. So the center of gravity of an object is defined as the point through which its whole weight is appeared to act for any orientation of the, if it is clockwise orientation or if it is anti-clockwise orientation of the object. We discussed that in greater detail. Now the B part is saying outline an experiment to determine the center of gravity of an irregular shaped piece of cardboard. Yesterday we took the plain lamina sheet, and in lecture number 28 you can see that experiment. I'm not wasting my time to perform it again. If you are interested, you can see we did this experiment. See previous video, lecture number 28. Yesterday we did it. Okay, the C part is saying that discuss qualitatively the effect of the position of the center of gravity on the stability of a table lamp. When the table lamp will be stable. Yesterday we discussed two conditions. Table lamp will be more stable. Number one, if its center of gravity is low. If the center of gravity is lower, it will be stable. The second condition we studied yesterday, the base area is wide. If the base area is wide, the table lamp will be more stable. Okay, that was the whole story about C. Now we are turning our focus to question number 4, in which A part and then subpart 1 is saying explain why it is possible to balance a meter rule as at its midpoint, but it is not possible to balance a billiard cue tapering wooden rod is its midpoint. Yes, the meter rule is a piece of wood uniformly distributed, so its center of gravity will be exactly at its center. Now, but billiard ball cannot be balanced at the midpoint because Q is not having a uniformly distributed mass. It is not uniformly distributed. So that is the whole story about that. The second part is saying describe an experiment to show that when a billiard cue is in equilibrium with two known masses hanging from it, the clockwise moment acting about the fulcrum is equal to the anti-clockwise moment. Ladies and gentlemen, yesterday in third part of the MCQs we did, now we are converting it into experiment. We have to find the center of mass of this billiard cue which is not uniform. On one side there is a mass of 80 gram and the weight of this mass of wood is 100 gram. So the middle point is 20 from this and it is 30 on this side. We have to hang these two weights. If we are seeing clockwise and anti-clockwise, we have to find the center of mass first of it as well. So we found the center of mass during the experiment to be at 14 centimeter. So the total is this 30, and when we subtract this 14 from 30, it will come out to be 16 centimeter. Now clockwise rotation is 80 multiplied by this 20, and that is equal to 1600 Newton meter, and anti-clockwise is 100 and that 16 we found from the center of mass. If we are multiplying both sides, then it will give you 1600 Newton meter and 1600 Newton meter, which is clearly indicating that clockwise moment is equal to the anti-clockwise moment. We are doing the last part. Let me erase the whiteboard. Okay, let's do the B part now, and the B part of question number 4 is on page number 78. A painter of weight 1000 Newton, remember 1000 Newton, stands 1 meter from left hand end of a uniform plank which is 5 meter long. 5 meter long is this one, because 0.5 and 0.5, 1 meter and 4 meter is this. The total length of this plank is 5 meter long and weighs 800 Newton. The weight of the plank is 800. The plank is supported by two trestles, each 0.5 meter from opposite ends. Yes, it is P and Q. Both are 0.5 from the opposite end. It is shown in the figure. The diagram below shows the two upward forces P and Q acting on the plank due to the trestles. Number 1 part, copy the diagram of the plank and complete it to show any other forces which are acting on it. Name each of these forces. There are two forces other than shown, and that is normal force on terrestrial P, which will be upward, and normal force on terrestrial Q, which will also be upward. The weight of the plank, which will be downward. Okay, the second part is saying what is the magnitude of the total downward force exerted on the terrestrials. So total downward force is equal to 1000, which is the weight of the painter, and 800, which is the weight of the plank. So it is 1800 Newton. The third part is saying what is the magnitude of the total upward force exerted by the trestle on the plank. So total upward force will also be 1800. If downward force is 1800, so same the reaction force or the contact force will also be equal to this. So 1000 plus 800 is equal to 800. Now the fourth part, which is the last part of this chapter, is by taking moments about the left trestle, calculate the upward force exerted on the plank by other trestle. So we have to use clockwise and anti-clockwise. 1000 by 5, 0.5, and then 800, uh, 2, because the middle of this 4 will be 2 here, and x multiplied by 4. The total is 4 and x. We have to find that x. So x is on the left side. This will give you 500 and this will give you 1600, and divide by this 4 Newton. So it will be 5 to 5 Newton. That's it, ladies and gentlemen. Hopefully, you have understood the things. Think on it, revise the video, see it again. And if you haven't yet subscribed, subscribe my channel and press the bell icon. Thank you very much for watching. Allah Hafiz.